So today I'm going to present a presentation on working of automatic weather station, data logger and sensors. Now you can see here, this is the block diagram of automatic weather station, which consists of weather sensor, data logger, then telemetry modem, tower, solar panel, monitoring software, etc. Now we'll see the components one by one, all the components of the automatic weather station. The first component is automatic weather sensors. The weather sensor measures the environmental parameters and transmits these signals to the data logging system. And then data logger captures all this weather data from the weather sensor and stores into its internal memory with current timestamp. And then remotely, all this data is being sent to the server using a GPRS modem. And and further this data is being saved or is being viewed through the weather station software. And all this data, all these sensors and data loggers, all these components, as you have seen earlier, the picture of the weather station, all these components are mounted on a tower with predefined heights and with proper enclosure. So now the next is data logger. This is the data logger basically. So data logger is important device in automatic weather station. So and it is the heart of the automatic weather station. Data logger is a device which acquires, processes, and stores the information and these parameters like temperature, humidity, wind speed, wind direction, barometric pressure, solar radiation. All these parameters are being recorded into the data logger. And the loggers which we are using, those are world-class and high accurate data loggers. And these are ruggedized data loggers so that these loggers are suitable for outdoor application and so that it can withstand in the outdoor environment. Now we'll see the more about the software and mobile application. This remote monitoring is the key feature of our weather monitoring system. The data logger is being accessed remotely from anywhere, anytime. You can access 24/7. You can access the data logger, and all these parameters are being uploaded on FTP server. Since those are uploaded on the FTP server, those can be monitored from anywhere. And further, you can generate the reports whenever you wanted to generate the reports, like daily, monthly, or yearly reports. You can generate those reports in PDF as well as Excel format. And apart from this, we have developed this kind of mobile application. So as nowadays everybody is using Android phones, so we have developed Android application, and these applications are available on Play Store, so that the users can download those applications and monitor our weather data. This is one of the latest development we have done in weather monitoring. And further, you can see the data in graphical, tabular, and statistical format. Now we'll see more about the sensors. All our sensors which we have developed and which we have manufactured, those are approved and calibrated by India Meteorological Department. Here you can see the calibration certificate from India Meteorological Department. Now the first sensor is temperature sensor, temperature and humidity sensor. So this is temperature and humidity sensor. In this temperature and humidity, both combined sensor are installed in this, and this is the Stevenson screen. Sensor is placed inside this Stevenson screen so that it can accurately measure the temperature and humidity. Also, this Stevenson screen protects this sensor from the solar radiation as well as rainfall and other environmental conditions. And this temperature sensor, we are glad to tell you that we have achieved 0.1 degree centigrade accuracy, which is the best accurate sensor, and which is better than Class A accuracy, and these are certified by IMT. And this temperature sensor range is -40 to +60 degrees centigrade. So we can use it in all the operating temperature of the operating temperatures. The next is humidity sensor. Humidity sensor is also placed inside this Stevenson screen. This range of this humidity is 0 to 100% RH. In market, there are the sensors which record only 10 to 90% RH, but we are covering all the ranges, that is 0 to 100% RH. Accuracy of this sensor is 2% of RH. Next sensor is air pressure sensor. This air pressure sensor is being used to measure the atmospheric pressure. So by measuring the air pressure, you can do the forecasting of the rainfall. If the pressure sensor goes down, pressure range or pressure reading goes down below 1000 hectopascal, then there is a possibility of rainfall on that day. So you can do short range forecasting using by observing the reading of the pressure sensor. The next is solar radiation sensor. We call it as pyronometer. So this pyronometer measures the solar radiation which are receiving from the sun. This is the important sensor that's the plant growth, which depend on the solar radiation. And then the next sensor is wind speed sensor. We call it as curve pyrometer. You can see the three curves are there. And those are moving as per the rate of the wind speed. And also there is one more principle, that is ultrasonic principle. Those type of sensors are also available with us. The range of this sensor is 0 to 60 meter per second. Even we have one more range, that is up to 0 to 100 meter per second. That is 0 to 360 kilometer per hour. And the accuracy of this sensor is 3%. The next sensor, if you'll see, that is the wind direction sensor. We call it as wind vane. Okay, this moves as per the wind direction. And this range is 0 to 360 degree. The accuracy is 3%. Then one of the important sensor, that is the next sensor is rain gauge sensor. This is the rain gauge sensor. This is one of the important sensors. So in this assembly, you can see here, this is the tipping bucket type of rain gauge. Okay, the water is getting collected in this tipping buckets. Okay, the resolution of this sensor is very high. That is 0.2 mm. So even if the 0.2 mm rainfall occurs, we could able to measure that rainfall, and its range is unlimited. And the next sensor is soil temperature and soil moisture sensor. It is a combined sensor which measure temperature and soil moisture both. In this, temperature sensor is used and moisture sensor is used. The range of this sensor is 0 to 239 kilopascal. By using this sensor and installing these sensors in the farm, we can control the irrigation, that is water supply required to the crop as per the requirement. Then the next sensor is pan evaporimeter sensor. This sensor is being used to measure the evapotranspiration rate of the water. Yes, so these are the slides from my side. Thank you very much, all of you, for listening my words. Now our director, sir, Mr. Shantanu Pendarkar, sir, will continue the further presentation. Thank you.